Hi, we are Group 5 from Cash 3.
I'm Adelyn, Wong, Xuan.
I'm Tay Jia Min.
I'm Lim Le Han.
I'm Ting.
And I'm Lau Jo Yi.
Today, our group would like to talk about augmented reality AR.
Here, we are going to talk about definition of AR, history of AR, basic component, application, and the last one we're going to talk about pros and cons of AR. So, what is augmented reality AR? AR is an interactive experience that combines the real world and computer-generated 3D content. The content can span multiple sensory modalities including visual, auditory, haptic, somatosensory, and olfactory. AR can be defined as a system that incorporates three basic features: a combination of real and virtual worlds, real-time interaction, and accurate 3D registration of virtual and real objects. The overlaid sensory information can be constructive or destructive. As such, it is one of the key technologies in the reality-virtuality continuum. This experience is seamlessly interwoven with the physical world such that it is perceived as an immersive aspect of the real environment. In this way, augmented reality alters one's ongoing perception of a real-world environment, whereas virtual reality completely replaces the user's real-world environment with a simulated ones.
So now I'll talk about the history of AR. At 1968, Ivan Sutherland, often considered the father of computer graphics, so he had created the first head-mounted display system called the Sword of Damocles. This device, although rudimentary and extremely bulky, laid the groundwork of future AR development by overlaying simple wireframe graphics onto the user's view of the real world. At 1974, Myron Kruger developed VideoPlace. It is an artificial reality laboratory that allows users to interact with virtual objects and environment. And although it is not AR in the modern sense, but it contributed to the understanding of human-computer interaction. At 1980, research into AR continued primarily in academic and military settings, so it focusing on improving head-mounted displays and exploring potential applications such as flight simulation and navigation. In 1990, Tom Cowdell, a Boeing researcher, coined the term AR while developing a system to help workers assemble aircraft by overlaying virtual diagrams onto physical components. In 1992, Lewis developed the virtual fixture system at the US Air Force Armstrong Labs. So this system used robotic arms and a stereoscopic display to overlay virtual guides onto the real-world tasks and enhancing the precision and efficiency. So in 1999, Hirokazu Kato developed the AR Toolkit. It is an open-source software library that enables the creation of AR application using computer vision techniques. So this toolkit made it easier for developers to experiment with AR and create new applications. At year 2000, the first AR browser, AR Quake, was developed, and it allowed users to play a modified version of the game Quake in an outdoor environment using a head-mounted display and GPS. In 2008, the release of smartphones with cameras, GPS, and powerful processors such as the iPhone paved the way for mobile AR application. The app Wikitude was one of the first AR browsers for smartphone, overlaying information about points of interest onto the camera view. At 2009, the LiAR app was launched, allowing users to view AR layers on their smartphone screens, providing information about their surroundings. At 2012, Google announced Google Glass, and it is a wearable AR device that displays information in a hands-free format. Although it faced privacy and usability concerns, it sparked significant interest in wearable AR technology. At 2016, Pokemon Go, developed by Niantic, became a global phenomenon. It demonstrating the potential of AR for mainstream entertainment. The game used smartphone cameras and GPS to overlay virtual Pokemon onto real-world location. And about 2017, Apple introduced ARKit and Google introduced AR Core, development platforms that made it easier for developers to create AR applications for iOS and Android devices, respectively. So these platforms significantly boost the number and quality of AR apps available to consumers.
The hardware components of augmented reality include mobile devices, for example, smartphones and tablets. Next, wearable devices, for example, AR glasses or headsets like Microsoft HoloLens or Google Glass that overlay digital content onto the real world. Next, camera and sensors and depth sensors that capture the environment and determine distances between objects. Besides that, the camera that captures the real world for overlaying virtual elements. Lastly, GPS, accelerometer, and gyroscope that provide location-based services and track device orientation. Next, for the software components of augmented reality, we have the AR Software Development Kit, or also known as SDK. Platforms like ARKit, Apple, and AR Core, Google, provide tools to create AR applications, handling tasks like motion tracking, environmental understanding, and light estimation. Other than that, we have computer vision algorithms, and these algorithms recognize and process real-world objects to accurately overlay virtual content. Next, we have rendering engine, where it combines real-world camera feeds with 3D virtual objects and displays them seamlessly. Lastly, for the components of augmented reality, we also have user interaction. Firstly, we have real-world augmentation where digital content like images, animations, or data is superimposed onto the real-world environment. Next, we have interaction via touch or voice in mobile AR, where users typically interact with virtual elements via touchscreen inputs or voice commands, for example, in apps like Snapchat or Pokemon Go.
The first application of augmented reality is entertainment and gaming. AR adds virtual elements to real-world games like Pokemon Go, which create immersive and interactive gaming experiences. The second application of augmented reality is retail and e-commerce. Shoppers can see how products like furniture look in their homes before buying. The third application of augmented reality is education and training. AR can bring textbooks to life by overlaying 3D models, animations, and interactive content such as human body or historical objects, which make learning more engaging and effective. The last application of augmented reality is navigation and travel. AR can provide real-time directions, points of interest, and other navigation aids overlaid onto the user's views of the real world. Besides that, tourists can use AR to access historical information, translations, and interactive guides while exploring new places.
Cons of augmented reality includes distraction risk, where it could distract users from their physical surroundings. Besides that, privacy issues is another cons of augmented reality. It raises privacy issues if this data collected is not properly managed. Furthermore, hardware limitations. The quality of augmented reality experiences depends on the hardware used, for example, the camera resolution and also the processing power. Lastly is development complexity. Creating good augmented reality experiences requires expertise in both software and hardware.
Thank you very much!